Good morning. Myself P. Vanitha, working as Associate Professor in the Department of Electrical and Electronics Engineering. Today I am going to present about wind energy, which is an important renewable energy source. This topic is from the subject of power electronics for renewable energy systems. In this presentation, I will explain the basic principle of wind energy conversion, advantages and disadvantages, components of wind energy systems and different types of wind turbines. Wind energy is the kinetic energy of moving air. This energy is captured using wind turbines. When wind flows across the turbine plates, it causes them to rotate. The rotating plates spin to shaft connected to a generator which converts mechanical energy into electrical energy. Wind turbines are also available in different sizes. Small turbines are used for homes or remote locations, while large turbines with rotor diameters over 100 meters can generate several megawatts of power for utility grids. Many countries like the USA, China, India, and European nations are used by wind power as a major renewable energy source. First, let us see the advantages of wind energy. Wind energy is a free and renewable source of power. It does not produce harmful emissions and it does not pollute air or water. Wind farms are also relatively inexpensive to build compared to some traditional power plants. Another benefit is that the land around wind turbines can still be used for agriculture. However, wind energy also has come some disadvantages. Wind speed is not constant and varies with time and location. So power generation can fluctuate. Wind farms require large areas of land. They can also cause visual impact and noise, which may affect nearby communities. The basic principle of wind energy conversion is to convert wind kinetic energy into electrical energy. When wind strikes the turbine plates, it creates aerodynamic forces that cause the plates to rotate. This rotation turns the rotor shaft, which is connected to a generator. The generator converts this mechanical motion into electrical power. This process forms the basic working principle of all wind turbines. The wind energy conversion system or WICS consists of several important components. These include the rotor blades, hub, gearbox, generator, controller, tower and foundation. The rotor blades capture wind energy. The hub connects the blade to the shaft. The gearbox increases the speed of rotation. The generator produces electricity. The controller manages the turbine operation while the tower supports the entire system at a higher height where wind speeds are stronger. The pitch control is used to control the angle of the turbine blades. By adjusting the blade angle, the system can regulate how much wind energy is captured. The pitch control system usually uses electric motors or hydraulic cylinders. It works as a closed loop control system that adjusts the blade angle depending on wind speed, generator speed and power output. This helps maintain safe and efficient turbine operation. The yaw control is used to orient the turbine toward the wind direction. Wind direction often changes, so the turbine must rotate to face the wind. In large wind turbines, a yaw motor rotates the wind nozzle so that the water blades remain perpendicular to the wind. In smaller turbines, this alignment is achieved using a tail vane. Wind turbine rotors rotate relatively slowly, usually around 40 to 50 rpm. However, generators require much higher speeds, typically around 1500 rpm. Therefore, a gearbox is used to increase the rotational speed from the rotor shaft to the generator shaft. Fixed ratio gears are commonly used because they are efficient and reliable. A generator is a device that converts mechanical energy into electrical energy. In wind energy system, the rotating blades of the turbine provide the mechanical input and the generator converts the rotating energy into electricity. Based on the power output capacity, wind aero generators are classified into three types. First, small generator, which produce up to 1 kilowatt of power. These systems usually use permanent magnet DC generators because they are simple, compact and suitable for small application. The second one is the medium generator, which can produce up to 200 kilowatts. In this category, we commonly use permanent magnet DC generators, induction generators and synchronous generators, depending on the system design and efficiency requirements. Third, large generators, which produce more than 200 kilowatts up to several megawatts. Large wind turbines generally use induction generators or synchronous generators because they are suitable for high power generation and grid connected systems. Uh, the schemes for electric power generation, there are three main schemes usually in wind power systems. The first one is constant speed, constant frequency system. In this system, the turbine operates at a constant speed. The second scheme is variable speed, constant frequency. Here the turbine speed can vary depending on the wind conditions, but power electronic converters maintain a constant output frequency. The third scheme is variable speed, variable frequency. In this method, both the turbine speed and the output frequency can vary according to the wind speed and operating conditions. This diagram shows the block diagram of a wind energy conversion systems. First, wind acts as a input. Wind acts as a input and rotates the aero turbine, converting wind energy into mechanical energy. The yaw control adjusts the turbine direction according to wind direction, and pitch control regulates the blade angle to control power. The turbine shaft is connected to a gear system which increases the rotational speed. Through the coupling, this mechanical energy is transferred to the electrical generator. The generator converts mechanical energy into electrical energy, which is then supplied to the load or utility grid. The controller monitors parameters like speed, output power, generator, uh, generator temperature and sends control signals to maintain safe and efficient operation of the system. The controller manages the operation of the wind turbine. It controls the yaw system, pitch control, startup and shutdown process and monitors generated output. It also provides protection against extreme wind speeds, system faults and equipment malfunction, ensuring safe and efficient operation. The tower supports the turbine and generator at a higher height where wind speeds are stronger and more consistent. Different types of towers include reinforced concrete towers, pole towers, shell tube towers and struts towers. Towers also provide space for control equipment at the space. The foundation supports the entire wind turbine structure and ensures it remains stable. It is usually made up of reinforced concrete and securely anchors the tower to the ground. This strong base is necessary because wind turbines experience large mechanical loads during operations. Wind turbines are mainly classified into two types: horizontal axis wind turbines, vertical axis wind turbines. Among these, the horizontal axis turbines are the most widely used in commercial wind farms. In horizontal axis wind turbines, the rotor axis is parallel to the ground. These turbines usually have three blades and are mounted on tall towers. Can be classified as single-bladed, two-bladed, and multi-bladed turbines. Through three-bladed turbines are most common because they provide good balance and efficiency. This slide shows the types of horizontal axis turbines based on the number of blades. First is the single bladed horizontal axis turbine. It has only one blade which with a counterweight on the opposite side to balance the rotor. It is lighter and cheaper, but it is not widely used due to the stability issues. The second is the two-bladed horizontal axis turbine. It has two blades and is simpler and lighter than multi-bladed turbine. However, it may produce more vibration during the operation. And the third is the multi-bladed horizontal axis turbine. These turbines have three or more blades and are the most commonly used in modern wind power plants because they provide better efficiency, smoother operation and higher stability. Horizontal axis turbines have several advantages. Their adjustable blade pitch allows them to capture maximum wind energy, and tall towers help access stronger winds. However, they also have disadvantages. They require a yaw control system. They may struggle in turbulent winds near the ground, and their large blades can make transportation difficult. In conclusion, wind energy is a clean, renewable, and sustainable source of electricity. Wind turbines convert the kinetic energy of wind into electrical power using various components such as rotors, gearbox, and generators. With increasing demand for clean energy, wind power will continue to play an important role in future energy systems. Thank you.